जी बेटा, अस्सलाम वालेकुम। अच्छा जी, टुडे वी आर गोइंग टू सॉल्व पेपर 4 ऑल्टरनेटिव टू प्रैक्टिकल ओ लेवल्स केमिस्ट्री। ठीक है जी। सो वी आर गोइंग टू सॉल्व P4 मई जून 2021 पेपर 41। ठीक है जी। अच्छा, वन मोस्ट इम्पॉर्टेंट थिंग अबाउट दिस पेपर, मोस्ट ऑफ द स्टूडेंट आस्क मी के कहाँ पेंसिल यूज़ करनी है, क्या करना है। तो एवरीथिंग इज़ मेंशन्ड इन द क्वेश्चन पेपर, यू जस्ट हैव टू रीड द इंस्ट्रक्शंस थॉरली। ठीक है, जो पहला पॉइंट है ये तो सिंपल देखने कि यूज़ अ ब्लैक और डार्क ब्लू पेन एंड यू मे यूज़ एन HB पेंसिल फॉर एनी डायग्राम और ग्राफ्स। तो इट्स बेटर कि आप डायग्राम और ग्राफ जो है वो पेंसिल से बनाएं। ठीक है, सो ये चीज़ सिंपल आप ध्यान में रखें। बाकी उसके अलावा सब चीज़ें क्लियर है आपको। P4 में देयर इज़ नो पीरियोडिक टेबल इंक्लूडेड इन P4, सो इफ देयर इज एनी क्वेश्चन रिलेटेड टू दी कैलकुलेशंस, सो जो भी एटॉमिक मासेस हैं इट वुड बी गिवन इन द क्वेश्चन पेपर। ऑलराइट, सो लेट्स स्टार्ट विद क्वेश्चन नंबर 1. In question number 1 it says that a student uses dilute sulfuric acid. Now the most important thing about this paper is, first of all, you have to manage your time because you have only 1 hour, right? And you have to manage your paper in this time period. So this is very important that you're completing the paper in time, right? So, and another important thing is that read the questions thoroughly. In P4 this is very important, although this is important for all the papers, but in P4 mostly mistakes occur when you do not read the question thoroughly. So read the question thoroughly, underline the important points, right? And anything which is in bold letters in question, this is very important, right? So हर चीज़ को आपने thoroughly पढ़ना है, क्वेश्चन को thoroughly पढ़ना है, समझना है, उसके बाद आपने अपना आंसर देना है. So this is very important when you are solving P4. So question number 1 is, a student uses dilute sulfuric acid and copper 2 carbonate to make a pure dry sample of blue copper 2 sulfate crystals. So what he is doing, he is using sulfuric acid and copper 2 carbonate, sulfuric acid and copper 2 carbonate as reactants to make pure dry sample of blue copper 2 sulfate crystals. So basically salt preparation hai. Dilute sulfuric acid is colorless and copper 2 carbonate is an insoluble green powder. All the carbonates are insoluble, so copper 2 carbonate is an insoluble green powder. Alright, and dilute sulfuric acid is colorless. Now they're saying the equation for the reaction is shown. Sulfuric acid reacting with copper 2 carbonate. This is acid plus metal carbonate. We get salt, carbon dioxide and water. The student uses one of the pieces of apparatus shown in the diagram to measure 20 cm cube of dilute sulfuric acid. Pour the dilute sulfuric acid into the other piece of apparatus as shown in the diagram. So he uses one of the apparatus to measure sulfuric acid and he then pour that sulfuric acid into another piece of apparatus. So name the apparatus the student uses to measure the acid. Right, so they're asking about the apparatus which he uses to measure the acid. So basically this is the apparatus he would use to measure the acid, right? And this is known as, I hope everyone knows the name of this apparatus, this is measuring cylinder. So he uses measuring cylinder to measure the acid, and next name the apparatus to which the student pours the acid. So he pours the acid into this apparatus. This is conical flask. Right, this is conical flask, or we can also call it a Linmeyer flask. The student adds solid copper 2 carbonate to the dilute sulfuric acid until the reaction is finished. Means once he added, this is dilute sulfuric acid H2SO4, and then he added copper 2 carbonate into it, CuCO3. He added copper 2 carbonate, which is solid. He added copper 2 carbonate into this. So the student adds solid copper 2 carbonate to dilute sulfuric acid until the reaction is finished and the copper 2 carbonate is in excess. Describe two observations which shows that the reaction is finished and the copper 2 carbonate is in excess. So they're saying that he adds solid copper 2 carbonate, he adds solid copper 2 carbonate to dilute sulfuric acid, and कब तक ऐड करता रहेगा until the reaction is finished and the copper 2 carbonate is in excess. Now the question is, describe two observations which shows that reaction is finished and the copper 2 carbonate is in excess. How would the student know कि जी reaction finished हो गया है and the copper 2 carbonate is in excess? So whenever they ask you for the observation means like you don't have to write any names that this gas would produce or this compound would form. You just have to write if there is any color change, if the gas is being produced. For example, how would he know कि reaction complete हो गया है? As you can see that in this reaction we are getting this carbon dioxide, right? And carbon dioxide is being produced, so that means we are getting effervescence. Carbon dioxide is insoluble in water, very slightly soluble, so that means we get effervescence. So once this effervescence stops or fizzing stops, that means reaction is completed. So how would he know that the reaction complete ho gaya? We can say that no more effervescence, no more effervescence or fizzing. So when effervescence or fizzing stops, that means reaction is completed, no more gas is being produced. So this is how he would know that the reaction finished हो गया. And how would he know that copper 2 carbonate is in excess? Copper 2 carbonate, they have already told us that this is an insoluble green powder. So when you get undissolved solid, or because he is adding this copper 2 carbonate into this solution and it is converting into copper 2 sulfate, but once it stops dissolving, तो वो जो आप कह लेंगे जो डिजोल्व नहीं होगा वो आपको सोल्यूशन के अंदर नजर आएगा ग्रीन सॉलिड की फॉर्म में. सो दैट ग्रीन सॉलिड वुड बी रिमेन इनटू द सोल्यूशन. सो हाउ वुड ही नो कि कॉपर 2 कार्बोनेट इज इन एक्सेस? ग्रीन सॉलिड अनडिजॉल्व्ड. ठीक है जी. एंड देन द स्टूडेंट फिल्टर्स द रिएक्शन मिक्सचर. He filters the reaction mixture through filter paper in a filter funnel. Describe the appearance of the residue on the filter paper and the filtrate after filtration is complete. So appearance of the residue on the filter paper. So once you filter the solution, obviously जो ये आपके पास insoluble copper 2 carbonate है green, ये as a residue आपको collect होगा. So that means the appearance of the residue on the filter paper. Appearance of the residue on the filter paper would be green solid, and the appearance of the filtrate. Now what would be the filtrate? Filtrate would be this copper 2 sulfate, and copper 2 sulfate, this is of blue color, right? So the color of copper 2 sulfate, you must remember that copper 2 sulfate is a blue colored solution. So the appearance of the filtrate would be blue solution. Alright, now this is the second question. This question is related to graph plotting. Alright, let's start with this question. They're saying a student investigates the effect of concentration on the energy change in a neutralization reaction. Effect of concentration on the energy change. That whatever the energy change is coming in the reaction, what is the effect of concentration on that energy change? If we change the concentration, so उससे energy change पे क्या effect आना है? So this is what he is investigating. So the student, अब now they're describing कि जी किस तरह से experiment हो रहा है. So the student measures 25 cm cube of aqueous sodium hydroxide in a beaker. ठीक है जी. So let's suppose this is the beaker. This is the beaker, and he took 25 cm cube of sodium hydroxide. Measures the temperature of this solution. So that means के इसमें simple है इसने thermometer. Let's say this is thermometer. So he measures the initial temperature and adds 25 cm cube of 0.1 mole per dm cube hydrochloric acid to the beaker. So he added 25 cm cube of known concentration of hydrochloric acid to the beaker, right? So let's say this is hydrochloric acid 25 cm cube, and once he would add acid, the reaction between acid and base will start and there will be some sort of energy change, and this is what he's investigating, right? So measures, and then he measures and record the highest temperature of the solution in the beaker. So when he adds the acid into the base, we know this thing that neutralization, this is an exothermic reaction. This is an exothermic reaction, and what happens in exothermic reaction, temperature rises. The temperature of surroundings will rise. So he would measure and record the highest temperature, कहाँ तक जाएगा temperature of the solution in the beaker, and repeat the experiment with different concentration of hydrochloric acid to find out what is the effect of concentration on the energy change. The diagram shows the highest temperature reached for 0.1 mole per dm cube and 0.5 mole per dm cube hydrochloric acid. Right, so they have given us two concentrations, 0.1 and 0.5. Now what we have to do, the initial temperature of NaOH and the HCl for all experiments is 20 degrees centigrade. So this was the initial temperature before adding hydrochloric acid. Record the highest temperature and the temperature changes in the table. So highest temperature, that would we have to see from these diagrams. So the highest temperature with 0.1 mole per dm cube is 20.8. 20.8. So this would be 20.8, and in case of 0.5 mole per dm cube, this is 23.5.6. 23.6. All right, and then we have to write the 20.8 and 23.6, and then we have to write the temperature change. Now how to calculate the temperature change? We know initial temperature and we know the final temperature, so just have to subtract final temperature or the highest temperature from the initial. So 20.8 minus 20.0, that would be 0.8. So the temperature rise in case of 0.1 mole per dm cube is 0.8 degrees centigrade, and in case of 0.5, that would be 23.6 minus 20.0, so that would be 3.6 degrees centigrade. So that means concentration is directly proportional to the energy change, because as we are increasing the concentration, temperature change is also increasing. ठीक है जी. So now the next part is, another student repeats the experiment for 8 different concentration of hydrochloric acid and record the temperature changes. The results are shown in the table. So these are the results of another experiment performed by another student, and he took 8 different concentrations and find out the temperature change. The temperature change for 0.7 mole per dm cube HCl is anomalous. Now as we can see that when we are increasing the concentration, 0.1 से 0.3, 0.3 से 0.5, temperature change भी बढ़ रहा है, 0.6 से 2.0, then 3.4. But when we increase the temperature from 0.5 to 0.70, temperature decreases from 3.4, it decreases to 2.6. And then again, when we are increasing the concentration, temperature is rising, right? So that means this result is not following the trend, right? On increasing the concentration, temperature change is decreasing, temperature is decreasing. So that means this is an anomalous result. So any result which does not follow the trend is an anomalous result. So the temperature change for 0.7 mole per dm cube HCl is anomalous. It is not following the trend, not following the trend, and this is obviously due to some sort of mistake. So suggest what the student should do to check that this temperature change is anomalous. So how to find out that this temperature change is anomalous? Whenever you have some anomalous result, just to find out whether this is anomalous or not, or this is the correct value or not, you just simply repeat the experiment, right? Because it might happen that in the first time you get the wrong reading. So just to make sure कि correct value क्या है, you have to repeat the experiment. So whenever they ask you कि जी anomalous result को कैसे check करना है, तो उसका simple एक ही answer है हमेशा कि repeat the experiment. You must repeat the experiment. ठीक हो गया जी. Next part of the question is कि plot the points of the temperature change, y-axis. Temperature change is on y-axis and concentration of hydrochloric acid is on x-axis on the grid. ठीक है जी. आपने इन रीडिंग्स के साथ ये जो रीडिंग्स हैं, इन रीडिंग्स के साथ आपने ग्राफ प्लॉट करना है। तो मैंने ग्राफ ऑलरेडी प्लॉट किया हुआ है, ठीक है जी। दिस इज़ द ग्राफ। दे वर सेइंग दैट, अच्छा ये आपके पास टोटल कितनी वैल्यूज़ हैं? इन टोटल वी हैव 1 2 3 4 5 6 7 8 वैल्यूज़ हैं। So basically this is 1 2 3, this is the anomalous one. Just remember this thing that anomalous result would be shown by this circle, and the other points through which you're drawing the graph, they should be shown through these crosses. So 1 2 3 4 5 6 7, and this is the anomalous. So total 8 points, right? And they were saying that draw one straight line of best fit for concentration up to 0.9 mole per dm cube, right? So up to 0.9 mole per dm cube. I've already completed the graph because there were two different lines. So draw one straight line of best fit for concentration up to 0.9 and a second straight line through the other 3 points. So this was the line up to 0.9, one straight line. This is 0.9. This is the point at, this is 0.9, right? And this is the second line. This is the second line, and then we have to extend both straight lines until they intersect. So I've extended both the lines, and this is the point where they are intersecting with each other. This is the point where they are intersecting with each other. All right, so this is the graph, and now we have to find some values. Use the graph to determine the concentration of hydrochloric acid, which gives a temperature change of 5.4 degrees centigrade. So 5.4 degrees centigrade, this is 5.4, 1 2 3 4, this is 5.4. So at 5.4 degrees centigrade, this is the point on the x-axis. So that would be 0.7, 0.72, 0.74, 0.76, 0.78. So this would be 0.78. Use the graph to determine the change for 1.4 mole per dm cube. The temperature change for 1.40 mole per dm cube HCl. So this is 1.40 mole per dm cube and 1.40 mole per dm cube per जो आपके पास change in temperature आ रहा है, that is 6.9. 6.9. Use the graph to determine the minimum concentration of hydrochloric acid that neutralize all the NaOH. Minimum concentration of hydrochloric acid that neutralizes all the NaOH. NaOH is the limiting factor, HCl is in excess. So the amount of minimum concentration of HCl that neutralize all the NaOH, this would be the point where these lines are intersecting with each other. Because after this point, you can see that there is no change in the temperature, right? So we can say that this is the point where this is the minimum concentration of HCl needed to neutralize the NaOH. So we read the value on the x-axis. So this is 1.0. So the minimum concentration of HCl is 1.0 moles per dm cube. All right, and the last part is a major source of error in this experiment is heat loss. Energy change experiments, this heat loss is always the major source of error. Suggest how the student can reduce the heat loss. So there are many ways in which we can reduce. We cannot avoid heat losses, but we can minimize them. And the simple way to minimize is that use a polystyrene cup. Because we need an insulator, and polystyrene cup is a much better insulator as compared to a beaker. Right, so use a polystyrene cup or cover the beaker with lid or provide proper insulation or lagging side. So you can write any one of them, but सबसे आसान polystyrene cup है, तो वो ध्यान में रखें. This is just 1 mark question. This is the end of this question. All right, beta. Now this next question is related to qualitative analysis. Right, and it is saying that a student does a series of tests on a mixture of ionic compounds in aqueous solution. Complete the table. Right, so this is related to tests for cations and anions. Name any gas formed and describe the test used to identify these gases, right? If a gas is being produced, we have to name the gas, and the test that how would we identify which gas is present. So the test used to identify the gas must also be written, right? Now the first test is he used aqueous ammonia, added aqueous ammonia. Aqueous ammonia is added to the mixture, right? So he added aqueous ammonia to the mixture, and on adding aqueous, now we know this thing that aqueous ammonia is added to test for cation. So this is basically cation testing. So what happens is we get a green precipitate forms which is insoluble in excess aqueous ammonia. So a green PPT is forming, green precipitate is forming which is insoluble in excess, right? And if a green precipitate is forming, that means with aqueous ammonia, that means either it is chromium ion or it is Fe+2, because I hope everyone has memorized these tests for cations and anions. You can see that chromium with aqueous ammonia, it gives green PPT which is insoluble in excess. So either it is chromium or it is iron 2+, which gives green PPT which is also insoluble in excess with aqueous ammonia, right? So in aqueous ammonia, if we get green PPT and which is insoluble in excess, so that means this is either chromium or Fe2+ is present. So this would be the observation, right? Now the next test is aqueous sodium. Now to confirm that whether it is chromium ion or Fe2+, sorry, to confirm whether it is chromium or Fe2+, aqueous sodium hydroxide is added to the mixture. A green precipitate is formed which is soluble in excess aqueous sodium hydroxide, right? So a green PPT is forming which is soluble in excess aqueous sodium hydroxide. So in NaOH, if a green PPT is formed and which get dissolved in excess NaOH, that means it is chromium ion. As you can see that chromium ions, they form green PPT, but they are soluble in excess, gives a green solution. But if iron 2+ ions are present, again we get green PPT which are insoluble in excess. So the PPT of Fe2+ is insoluble in both NaOH and ammonia, and the PPT of chromium ion is insoluble in ammonia, but it is soluble in NaOH. So because they are saying that the PPT is soluble in excess aqueous sodium hydroxide, that means chromium ion is present, right? So chromium ion is present. Now the next part is they're saying the mixture is warmed. The mixture which we get is warmed, means when we added NaOH, let's suppose if this is the, let's say this is the test tube and it contains the unknown solution in which we are testing the cations and anions, and we added NaOH into it. So when we added NaOH, we get green PPT which get dissolved in excess, and once we are done with this test, then they are saying that the mixture is warmed. This mixture is warmed, right? And on heating the mixture, a gas is also produced which turns damp red litmus paper blue. So on adding NaOH, when we heat the mixture and we get a gas which turns damp red litmus paper blue, that means another cation is present in the mixture, and that cation is ammonium ion. As you can see, ammonium ion, NH4, it produces, when we add NaOH in the mixture which contains ammonium ion, ammonia produced on warming, and the test for ammonia gas is that it turns damp red litmus paper blue. So we can say that ammonia gas is produced, because in question it is clearly mentioned that name any gas formed and describe the test used to identify these gas. So ammonia gas is formed as it turns red litmus, because ammonia is basic, blue, and that means which cation is present? NH4+, ammonium ion is present. So that means this solution, this mixture contained two cations. Alright, next part is Now they are going to test the anions. Excess dilute nitric acid is added to the mixture. Excess dilute nitric acid is added to the mixture, right? And on adding excess dilute nitric acid, they have given us this observation that carbonate ions are in the mixture. Carbonate ions are in the mixture. So carbonate ions, basically carbonate ions are tested when we add any acid in the mixture. Acid will react with carbonate ions. Acid will release H plus ion, which will react with carbonate ions, and this would produce carbon dioxide gas and water. So how would we know that carbonate ions are present? Because on adding H plus ions, we get this carbon dioxide gas, which causes fizzing, and on passing this carbon dioxide gas, when we pass this CO2 gas through lime water, it turns milky. So this is how we get confirmed that carbon dioxide is present, and if carbon dioxide is being produced, that means which ion is present in the solution? Carbonate ion is present in the solution. So we have to, first of all, let me just write it here. In the conclusion, because we are saying carbonate ions are in the mixtures, that means which gas is being produced? Carbon dioxide is produced. Right, and how would we know? We are saying that on adding excess dilute nitric acid to the mixture, CO2 produces, that means fizzing occurs, colorless gas produces, which turn lime water milky. Right, so this is how we found out that carbonate ions are present in the mixture. Now the next part is saying that after adding dilute nitric acid, once we are done with this test, when we added dilute nitric acid, fizzing occurs and we pass the gas through lime water, it turns milky, that means carbonate ions are present. They're saying that once we are adding dilute nitric acid, then we add aqueous silver nitrate, and on adding aqueous silver nitrate, we get a conclusion that iodide ions are in the mixture. And iodide ions, how would we know that iodide ions are in the mixture? Because on adding silver nitrate, silver nitrate would release Ag plus silver ions, and these silver ions will react with the iodine ions if they are present in the solution, and this would give us a solid silver iodide which is insoluble, and this gives yellow precipitates. And if we get, on adding silver nitrate in a solution, if we get yellow precipitate, that means iodide ions are present in the solution. So we can say that yellow precipitate forms, that means iodide ions are present in the mixture. Alright, so carbonate ions are present, iodide ions are present in the mixture, and they're saying that sulfate ions are also in the mixture. So sulfate ions are also in the mixture, and we have to write the test as well as the observation. So what is the test for sulfate ion? Acidify with dilute acid, then add aqueous barium nitrate or barium chloride, whichever is present. So barium ions will react with the sulfate ions. If you write the ionic equation, barium ions will react with the sulfate ions to give white insoluble precipitate of barium sulfate. So we can say that on adding barium nitrate, white insoluble precipitate forms, and that means sulfate ions are present in the mixture. These sulfate ions are present in the mixture. Alright, so this is the end of this question. Alright, now this next question is related to designing experiment, right? In these kind of questions, you have to read the question very carefully and design the experiment in your mind or make some rough points and then write the final answer, right? So this is very important to read the whole description to understand that what we are doing, what we are starting with, and what things we have to keep constant and which apparatus will we use, right? So this is very important question, 9 marks question. All right. So let's just read this question, what they're saying. A mixture of aqueous iron 2 nitrate and aqueous sodium thiosulfate is purple. Alright, so we have a mixture of aqueous iron 2 nitrate and sodium thiosulfate, which is of purple color. A reaction takes place in the mixture. When the reaction is complete, the solution turns from purple to colorless. Means when iron 2 nitrate and sodium thiosulfate when they react with each other, the color of the solution changes from purple to colorless. Plan experiment to show that aqueous copper 2 sulfate increases the rate of this reaction. So we have to show that copper 2 sulfate can be used as catalyst in this reaction or not, whether it will increase the rate of reaction or not, right? So iron 2 sulfate, iron 2 nitrate and sodium thiosulfate, they are reacting with each other. Color changes from purple to colorless, and we have to find out that copper 2 sulfate can be used as a catalyst, can be used to increase the rate of reaction or not. You are provided with aqueous iron 2 nitrate, aqueous sodium thiosulfate, aqueous copper 2 sulfate, and the apparatus normally found in the school laboratory. Alright, now the most important part is this one. Your answer should include, like, what you have to write, what you must have to mention in your answer. This is very important. A method which include the name of the apparatus you would use and the variables you would control. Name of the apparatus and the variables you would control. Next, the measurements you need to make during your experiment. Measurements, which measurements you would make to prove your experiment. The results you expect, what results you would expect. Any explanation of how the result shows that copper 2 sulfate increases the rate of the reaction, right? So these are the 4 points that you must mention in your description, right? So first of all, how would we do this experiment? Now this kind of reaction, we haven't studied these reactions in our syllabus, but they have provided you whole information. Like they are telling you that when these two substances, iron 2 nitrate and sodium thiosulfate, react with each other, the color of the solution changes from purple to colorless. You just have to find out whether copper 2 sulfate can be used to increase the rate of reaction or not. So how would we do this reaction? Let's suppose first we react iron 2 nitrate and sodium thiosulfate in the absence of catalyst. So we would take a conical flask. Alright, so let's say this is the conical flask. We use this conical flask and we add iron 2 nitrate. Let's say this is iron 2 nitrate and sodium thiosulfate. Sodium thiosulfate in this, right? And when these two react with each other, the color changes from purple to colorless. So to find out that the time in which it changes color, we would use stopwatch. Stopwatch would be used to measure the time in which it changes color. So we would start with our points that take a conical flask and add aqueous iron 2 nitrate and sodium thiosulfate Take a conical flask and add aqueous iron 2 nitrate and sodium thiosulfate of known volume and concentration at a particular temperature. So these conditions must be known, that at what volume we have added, what concentrations we are using, and at what temperature we are doing this experiment, right? So note the time in which color changes from purple to colorless. Note the time in which color changes from purple to colorless. So now we have the time. Let's suppose this whole experiment, it occurs in, let's say, 50 seconds. Right, let's just assume that it occurs in 50 seconds, the color of the solution changes from purple to colorless. Now, we have to find out that whether copper 2 sulfate can be used as a catalyst or not. So now we would repeat the experiment, but this time adding copper 2 sulfate. So repeat the experiment, add, but this time add CuSO4, copper 2 sulfate, in addition to barium nitrate, in addition to iron 2 nitrate, in addition to iron 2 nitrate and sodium thiosulfate. Right, so repeat the experiment, but this time add copper 2 sulfate, because we have to find out that whether it can be used as a catalyst or not, in addition to iron 2 nitrate and sodium thiosulfate. Keep the concentration and volume of the reactants similar to experiment A and perform the reaction at the same temperature. Right, perform the experiment at the reaction at the same temperature and note the time in which, now this time we have added copper 2 sulfate, so note the time in which color disappears. Right, so now what we have done, we have included the name of the apparatus we would use and the variables you would control, temperature, volume, concentration, the measurement you need to make during your experiment. So we had measured the time in the absence of copper 2 sulfate. Now we have the time in the presence of copper 2 sulfate. So both the times are mentioned, and the results we expect would be the experiment in which CuSO4 is used would have a shorter time. It would have a shorter time, and that means, so it would have a shorter time. This is the results we expect, and the explanation of the how results shows that copper 2 sulfate increases the rate of reaction. So it have a shorter time. It means its rate of reaction is high. Right, so this would be the experiment. Alright, so what we have done, we have taken a conical flask and add aqueous iron 2 nitrate and sodium thiosulfate of known volume and concentration at a particular temperature. Right, note the time in which, how would we note the time? Using stopwatch. So note the time in which color changes from purple to colorless. Now repeat the experiment, but this time add copper 2 sulfate, because you want to find out whether it can be used as a catalyst or not. Add copper 2 sulfate in addition to iron 2 nitrate and sodium thiosulfate. Keep the concentration and volume of the reactant similar to experiment A, so that results can be matched, and perform the reaction at the same temperature. Note the time in which color disappears. So we have the time in which color disappears in the absence of copper 2 sulfate, and now we have the time in which the color disappears in the presence of copper 2 sulfate. So what we are expecting is that the experiment is short. The experiment in which copper 2 sulfate is used would have a shorter time. This reaction would occur at a faster rate, and it means its rate of reaction is high. Right, so this is how we can determine that copper 2 sulfate increases the rate of reaction. First we do the reaction in the absence of copper 2 sulfate, and then we do the reaction in the presence of copper 2 sulfate. So if the reaction occurs at a faster rate in the presence of copper 2 sulfate, that means copper 2 sulfate is acting as a catalyst. All right. Ji beta, this is the next question, question number 5. And this question says that a student investigates a solid metal carbonate using 2 different methods, right? He's investigating a solid metal carbonate. We don't know which metal it is, and he's investigating it using 2 different methods. Now, the first method is the student, they have given us the whole method. The student measures the mass of an empty test tube. All right, here's an empty test tube. Let's suppose this is the empty test tube. He measures its mass. All right, added some metal carbonate to the test tube and measures the mass again. Next, he added some metal carbonate. Let's say this is some metal carbonate he added, and then he noted the mass again and heats the test tube strongly, then let it cool. And then what he did, he simply heated the test tube. After once he transfers the metal carbonate into the test tube, then he heats the test tube strongly and then let it cool. And once it's cooled down, then measures the mass of the test tube and contents again. All right, because once we know this thing that metal carbonates, they get decomposed on heating. So any metal carbonate will decompose to give metal oxide, except for group 1 metal carbonates. So metal carbonate, group 1 carbonates do not get decomposed. So this carbonate will decompose to give metal oxide and carbon dioxide, right? So as carbon dioxide would be released, so therefore the mass will decrease as well. So therefore he would take the mass again. So heat the test tube a second time, then let it cool, then measure the measure the mass of the test tube and content again, then heat the test tube a third time, right? He's heating the test tube, then it cools down, then he takes the mass, then he again heat the test tube. So he's repeating the experiment again and again, and he repeats the experiment 3 times. So he repeats the experiment 3 times. The student results are shown in the table. All right, so this is the table they have given us and all the results as well. So this is the mass of empty test tube, 59.14. Then the test tube and metal carbonate before heating. When he added metal carbonate, the mass becomes 63.34. Test tube and contents after first heating was 61.78. Then after second heating 61.14, and after third heating 61.14. So second and third heating we get the same mass. That means after second heating the reaction was completed, right? All right, so the question is, calculate the mass of metal carbonate used. We have to calculate the mass of metal carbonate. So we have the mass of empty test tube and test tube and metal carbonate. So we are simply going to subtract mass of metal carbonate plus test tube from mass of empty test tube. So the mass of test tube plus metal carbonate before heating was 63.34 minus the mass of empty test tube is 59.14. So this is 4.2. So the mass of metal carbonate that was used in the experiment is 4.2 grams. All right, next they are saying calculate the total change in mass of the contents of the test tube after heating. Total change, right? Total change means that when the mass gets constant. So after third heating we are saying that this gets constant. So initially the mass of the metal carbonate plus test tube was, before heating it was 63.34, and after third heating the mass of metal carbonate or the residue of metal carbonate and test tube is 61.14. So the change in mass is 2.2 gram, right? We have to calculate the total change in mass of the contents. So the total change in mass is 2.2 grams. All right, next they're saying explain why the student heat the metal carbonate 3 times. right? He has done 3 experiments. So explain why the student heat the metal carbonate 3 times. So why he's heating the metal carbonate 3 times? To make sure that all the to get the constant mass, or we can say that to make sure that the reaction is complete, to make sure that the reaction is complete, or we can say that to get a constant mass, right? Next part is the metal in the metal carbonate is represented by M. The equation for the reaction is shown. So this is the same equation I've given you in the start of the question. Metal carbonate decomposes to give metal oxide and carbon dioxide. Explain why there is a change in mass during heating. Why there is a decrease in mass? Because carbon dioxide is the gas, it is being released as CO2 gas is being released. All right, next part is related to calculations. The MR of carbon dioxide gas is 44. This is the molecular mass. Use your answer to A2 to calculate the number of moles of carbon dioxide made in the reaction. So in A2 we have calculated the change in mass. So this is the mass lost. This is the mass lost. So that means this is the mass of carbon dioxide, because carbon dioxide is being released. So we can say that the mass of carbon dioxide released is 2.2 gram. 2.2 gram was the mass of carbon dioxide which was being released. So they're saying that use your answer to A2. We have mass of carbon dioxide released to calculate the number of moles of carbon dioxide made in the reaction. So we have the mass of metal carbon dioxide, plus we have the molecular mass of carbon dioxide as well. So we know this thing that moles can be easily calculated. Mole is equals to given mass upon MR. So the mass released was 2.2 gram divided by MR is 44. So 2.2 divided by 44, that is 0.05. So these are the moles of carbon dioxide. All right, next part is use the equation. Use the equation to calculate the number of moles of metal carbonate used in the experiment. So we already have the moles of carbon dioxide, and now they're saying that by using the equation, calculate the moles of metal carbonate used in the experiment. So by simply taking the molar ratio, according to molar ratio, 1 mole of carbon dioxide is being released from 1 mole of metal carbonate, right? They're reacting, or they are in equation in 1:1 ratio. 1 mole of metal carbonate gives 1 mole of carbon dioxide. So that means if 0.05 moles of carbon dioxide is being released, that means the moles of metal carbonate that is being heated, it is also 0.05, because the molar ratio of metal carbonate and carbon dioxide is of 1:1. They are reacting in a 1:1 ratio, or they are in the equation in 1:1 ratio. ठीक है जी. Next part is use your answer to A1. In A1 we have the mass of metal carbonate that we have taken. So use your answer to A1 and C3. C3 is the moles of metal carbonate. So we have mass of metal carbonate that is being heated, and we have the moles as well. Calculate the mass of 1 mole of metal carbonate. So we can easily calculate the mass of 1 mole of metal carbonate, because we know the mass of 0.05 moles of metal carbonate. 0.05 moles of metal carbonate weighs 4.2 grams. So if I know the mass of 0.05 moles, 0.05 moles of metal carbonate weighs 4.2 grams. So 1 mole of metal carbonate weighs how many grams? So by cross multiplying, that would be equal to 4.2 divided by 0.05. So 4.2 divided by 0.05, that is 84. So mass of 1 mole of metal carbonate is 84. Next part is calculate the atomic mass of metal M, and they have given us the atomic masses of carbon and oxygen. This is the total mass of metal carbonate MCO3. We just have to subtract the mass of carbonate from this 84. So first let's calculate the mass of carbonate. In carbonate we have one carbon 12 and 3 oxygens, means 48. 16 3 is 48. So 12 plus 48, this is 60. So this is the mass of carbonate, and the total mass of metal carbonate is 84 minus the mass of carbonate, which is 60. So 84 minus 60, that means atomic mass of metal M is 24. All right, and the last part from this calculation is being removed from the question paper due to an issue with question 5C6. The question was being removed from the question paper. All right. Now, as they have told us in the start of this question that the student investigates metal carbonate using 2 different methods. So this was first method, and now the second method. Right, the second method is the student measures 0.2 grams of metal carbonate. Again, he measured, this time he's taking 0.2 grams of metal carbonate. Set up the apparatus shown in the diagram. Now what he has done, he has taken a conical flask filled with hydrochloric acid. Attach this conical flask with this gas syringe. This is gas syringe. So this time he's collecting the gas. All right. So what he's doing here is sets up the experiment shown in the diagram. Remove the bung. This is bung. Remove the bung and quickly adds the metal carbonate. So he removes the bung and then he adds metal carbonate, and then he again places the bung on the flask. Replaces the bung and measure the total. Once he replaces the bung, the gas would produce that as we add metal carbonate. Let's say this is metal carbonate we added. So we know this thing that metal carbonates reacts with acids to give salt plus carbon dioxide plus water. So as soon as we add metal carbonate in dilute acid, we get this carbon dioxide gas. So the carbon dioxide gas would escape the flask and will enter into the gas syringe, right? And we collect the gas in the gas syringe. So the name the apparatus used to collect the carbon dioxide, the apparatus used is gas syringe. State the volume of carbon dioxide collected. Volume of carbon dioxide collected. So this is 10, 20, 30, 40, 50, 54. This is 54. All right, so the mass volume of carbon dioxide collected is 54 centimeter cube. Calculate the number of moles of carbon dioxide collected. Moles of carbon dioxide. 1 mole of any gas at room temperature and pressure occupies 24 dm3. So this time we have volume of gas, and we know this thing that we can easily calculate the moles of any gas if we have its volume at standard temperature, at room temperature and pressure. At room temperature and pressure, any gas would occupy 24 dm3. So moles of gas would be given volume, which is 54, divided by, we just simply, because we have volume in centimeter cube, so we take this volume in centimeter cube as well. Right, so that would be 24 multiplied by 1000. So this is 24,000. So 54 divided by 24,000, that is 0.00225. This is the moles of carbon dioxide that is being released when 0.2 gram of metal carbonate is reacted with dilute acid. The student used this information to calculate the relative atomic mass of M. Right. Suggest a reason why method 2 is less accurate than method 1. All right. In method 2, in method 1, we were heating the metal carbonate. Gas was being evolved, and we were taking the mass of the remaining substance, the residue. Right, and in experiment 2, what we are doing, we are collecting the gas. So this method is basically less accurate because we are collecting the gas in this method, and obviously you have to remove the bung to enter the metal carbonate. This is what they have told us in this step. So there is a chance that the gas which is being produced, some of the gas might escape, right? Before you replace the bung, before you start your experiment, when you remove the bung to add metal carbonate, there are chances that some of the gas might escape, right? And due to which we will not get the actual result. So why method 2 is less accurate than method 1? Because some of the gas might escape or gas loss, right? Identify a hazard in method 2, and suggest a safety precaution to reduce the risk associated with this hazard. So the hazard in experiment 2 is that we are using hydrochloric acid, which is a toxic acid. So HCl is toxic or corrosive. So precaution is that wear gloves, safety goggles. All right, so this is the end of this question. All right, beta. Now this is the last question, and this is related to acid-base titration, right? Now they're saying that a student determines the concentration of dilute sulfuric acid by titrating it with aqueous sodium hydroxide, right? So he's reacting sulfuric acid with sodium hydroxide. The student transfers 10 centimeter cube of 0.1 mole per dm cube NaOH into a flask, conical flask. Add a few drops of methyl orange indicator to the flask and fills the burette with sulfuric acid. So he added NaOH in the conical flask and sulfuric acid in the burette. Then he adds sulfuric acid to the flask until the indicator changes color, like we do the titration process. And they have given us the 3 titrations that the student has performed. The diagram shows part of the burette with the liquid levels at the beginning and end of each titration. This is first titration, second titration, and third titration. Use the diagrams to complete the table. So the titration number 1, let's fill the table for titration number 1. Final burette reading. This is the final burette reading, and that would be 24.1.2. So this is 24.2. And initial burette reading, liquid level is at 0, so that would be 0.0. For second titration, this is 47.8. So that would be 47.8, and initial reading is 24.2. So that would be 24.2. For the third titration, the final reading is 24.8. 24.7. 24.7, and initial is 1.3. 1.3. Another thing, volume of acid added. So that would be final minus initial. So in experiment 1, this is 24.2. In experiment 2, so that is 47.8 minus 24.2, 23.6, and 24.7 minus 1.3, so that is 23.4. And finally, they're saying the best titration result. So the best titration results are always those which have minimum difference between them. So that would be experiment number 2 and experiment number 3, which has the experiment 2 has 23.6 value and the experiment 3 is 23.4. So a difference of 0.2. So that means experiment 2 and 3 are the best titrations. Use these results to calculate the average volume of sulfuric acid required to neutralize the NaOH. Average volume we have to calculate the average volume. So the average volume would be the average of the 2 best titrations. So the 2 best titrations are 23.6 plus 23.4 divided by 2. So that would be 23.5 centimeter cube. So this is the average volume of H2SO4 required to neutralize the sodium hydroxide. Next, they're saying calculate the number of moles of NaOH in 10 centimeter cube. This is volume of 0.1 mole per dm cube concentration of sodium hydroxide. So we have volume and concentration of sodium hydroxide, and we have to calculate the number of moles. So the number of moles, and volume and concentration have this relationship. V is equals to N upon V, or number of moles would be equal to C into V. So the concentration is 0.1 into volume is 10 centimeter cube. We have to convert it into dm cube, so that would be 10 divided by 1000, 0.01. So 0.01 multiply by 0.1, so the value is 0.001. All right, now the next part of this question is the equation for the reaction between sodium hydroxide and H2SO4 is shown. So they have given us this equation, right? Sodium hydroxide, 2 moles of sodium hydroxide reacting with 1 mole of H2SO4. So that means molar ratio of NaOH is 2:1. Calculate the number of moles of sulfuric acid. Number of moles of sulfuric acid that reacts with 10 cm cube of 0.1 mole per dm cube NaOH. So we already have calculated the moles of NaOH, and they have given us this equation, and now they want us to calculate the number of moles of H2SO4. So that would be obviously by using the molar ratio, as we know that 2 moles of sulfuric acid will react with 1 mole of H2SO4. So that means whatever the moles of NaOH we have, the moles of sulfuric acid would be half of that, right? So if we have 0.001 moles of sodium hydroxide, so that means number of moles of H2SO4 required to neutralize that much moles of sodium hydroxide would be half of that. So that would be 0.001 divided by 2. That would be equal to 0.0005, right? So you have to use the molar ratio from the given equation, which was 2:1. And now the last part is calculate the concentration of sulfuric acid in moles per dm cube. Give your answer to 3 significant figures. So the concentration is equals to number of moles upon volume. We have calculated number of moles, which is 0.0005 divided by volume was this average volume. This is in centimeter cube, so that would be 23.5. First convert it into dm cube. 23.5 divided by 1000, that would be 0.0235. So now we have 0.0005 divided by 0.0235. So the concentration of sulfuric acid is 0.021, as we have to give the answer in 3 significant figures. So that would be 0.0213. This is the final answer.